Hi, in this tutorial we are going to solve a question related to SN2 reaction. In this question we are going to compare the nucleophilicity, or being a good nucleophile or a bad nucleophile, or better nucleophile or a worse nucleophile. So the question is, you are given 4 pairs of nucleophiles. In each case state which species is expected to act as a stronger nucleophile in an SN2 reaction. If same substrate and solvent, possibly polar aprotic, are used, give a brief reasoning. Let's start solving the question. So in each pair we have to catch a trend basically in order to compare the nucleophilicity of given 2 nucleophiles. Let's look at the first case. In the first case, the first molecule is an alcohol, it's methyl alcohol, and the second one is its conjugate base. So basically the relationship between them is one is an acid and the second one it's a conjugate base. We know that in an SN2 reaction, the good nucleophile will be the more basic in general. So basically, a conjugate base is going to react faster than its acid form. So definitely this molecule, methoxide ion, let's circle it, it's going to be a better or a stronger nucleophile. Let's just circle this one because this is more basic than its acid form. So but again this comparison holds true if we are comparing very similar molecules like an acid and its conjugate base. Okay, let's look at the second one. We have water here as first molecule, and the second molecule is acetate anion. And if you look at, you will be easily able to decide acetate anion will be a better nucleophile, will be a stronger nucleophile because it's negatively charged, and water it's neutral. So let's circle this one. It's going to be a better nucleophile. Also it's related to acidity or basicity. Let's compare them. For example, if we are comparing not water versus acetate anion, let's say this is hydroxide. Hydroxide will be way better nucleophile than acetate anion. Why? Because it's going to be a stronger base, but its conjugate acid form is going to be a weaker nucleophile than acetate anion. Okay, let's move to the next option. In the next option, we need to compare the nucleophilicity of bromide anion versus fluoride anion. As you remember, if we move down in the periodic table in the same group, these are from 7A halogens, nucleophilicity increases as the size increases. So bromine is going to be more nucleophilic than fluoride anion. The reason is bromine has a larger atomic radius, and the last shell electrons are way away from nucleus. So these electrons at the last shell will be able to easily donate it to substrate. So that's the reason. So bromine or bromide anion will be able to donate its last shell electron easier than fluoride anion, because in fluoride anion last shell electrons are very close to nucleus. Okay, let's move to last option. We have NH3, ammonia, and versus water. Okay, again, like these two are similar molecules because they are both like having 3 hydrogens and 2 hydrogens, and we are in the same row in the periodic table. So this is the second row, nitrogen and oxygen. We know that nitrogen 5A, oxygen is 6A, and we know that oxygen is more electronegative than nitrogen. So if two of them will donate their lone pairs, which one will be easily donating? Nitrogen, since it's less electronegative and also atomic size is bigger than oxygen, will be able to easily donate its lone pair electrons when it's making bond with a substrate. So let's circle that. This will be more nucleophilic or stronger nucleophile than water. Thank you so much for watching.